Ever just stare at your computer and wonder what's really going on in there? When you click something or start typing, it can totally feel like this mysterious black box. Well, today we're going to pry that box right open. We're about to take a tour of what I'm calling the digital kitchen to finally make sense of how your computer actually works. And believe it or not, it all kicks off with one kind of weird question. So yeah, what on earth does a computer have in common with a crazy, busy professional kitchen? It sounds a little out there, I know, but just stick with me on this. This one simple idea, this one analogy is going to be the key to understanding, well, pretty much everything from why your computer sometimes grinds to a halt to how it can possibly juggle so many things at once. All right, so picture this. Your computer is a kitchen. All those programs and apps you're running, just think of them as recipes. And of course, every recipe needs two things: a cook to follow the instructions and a bunch of ingredients to work with. That's it. That's the whole setup, and it's going to be our guide for everything else. So, who's the cook in our kitchen? That would be the CPU, the central processing unit. This is our star chef. And look, this is no ordinary cook. This chef is so fast, they can follow billions, literally billions, of recipe steps every single second. Their speed is the absolute heart and soul of this whole operation. But a cook can't do anything without ingredients and a place to work. In our digital kitchen, the workspace is set up in a really smart way. There's a giant pantry for long-term storage, a countertop for whatever's being worked on right now, and a little spice rack for the stuff that's used all the time. Let's meet the crew.
First up, the pantry. This is your computer's storage, the hard drive or the SSD. It's massive. It holds all your recipes and ingredients, your programs and your data forever. Even if you shut the whole kitchen down, everything in the pantry is safe. It's super reliable, but walking all the way over to it takes time. Okay, next we've got the countertop. In the computer world, this is your RAM. Now, when the cook decides to make something, they're not going to run back and forth to the pantry for every single ingredient. No way. They bring what they need out and put it on the countertop for super quick access. It's way, way faster. But here's the catch. There's only so much counter space. And that brings us to the spice rack. This is the cache. It's this tiny but unbelievably fast little bit of storage that's built right next to our cook, the CPU. It's where you keep the salt and pepper, the ingredients the cook is reaching for constantly. Getting something from the spice rack is basically instant. So this whole system, the slow pantry, the faster countertop, the instant spice rack, it's all a balancing act. And that right there, that's the fundamental trade-off in how all computers work. The farther you get from the cook, the bigger and slower the storage is. The pantry is huge, but it's a long walk. The countertop is smaller, but it's right there. And the spice rack? It's tiny, but it's immediate. Getting this balance right is everything for your computer's performance. Now, you can imagine that a busy kitchen with lots of cooks and recipes flying around would be total chaos without someone in charge. In our computer, that someone is the operating system, the OS. You can just think of it as the head chef, the one who's directing all the traffic and making sure the kitchen doesn't burn down. In this head chef's job, it's absolutely critical. They're managing all the kitchen equipment, keeping tabs on every single recipe or process that's running. They're the one who decides which task gets to use the cook next. And they handle all those slow, painful trips to the pantry, what we call input-output. The OS is truly the ultimate kitchen manager. Okay, so this is the big question. If our cook, the CPU, is so ridiculously fast, why do our computers sometimes feel so sluggish? Well, the problem isn't the cook. The problem is all the waiting around. I mean, let's just try to wrap our heads around that speed for a second. A pretty standard 3 gigahertz CPU can perform 3 times billion basic operations every single second. It's moving at a pace that is it's hard to even comprehend. But all that speed means nothing if the cook is just standing there with nothing to do. So here's where this waiting game really hurts. Let's say we have a task that needs 100 million little steps. At the CPU speed, that should be over in a flash, like less than 0.2 of a second. But, and here's the catch, what if just 10% of those steps need an ingredient from the countertop, from RAM? Each trip takes about 100 nanoseconds, which sounds tiny, right? But it adds up. All those tiny delays suddenly add a full second of just waiting. And that right there is the bottleneck. Our lightning-fast cook ends up spending most of their time just tapping their foot, waiting for ingredients to arrive from the countertop. The actual cooking is instant. It's the waiting that's killing performance. So how do we fix this? The spice rack, the cache. By intelligently keeping the most used ingredients in that super fast storage right next to the cook, we can eliminate most of those trips to the countertop. A good cache system can slash that waiting penalty by a mind-blowing 90%. That lets our cook get back to what they do best, cooking. So now that we've got a handle on how the kitchen works, let's zoom out a bit. This whole system of cooks, countertops, and pantries gives us incredible power. But it also means there are some built-in trade-offs and some very common reasons why things, go wrong.
I mean, the benefits are pretty amazing, right? We get automation that's unbelievably fast. Computers do exactly what we tell them to perfectly, every single time. We can always make them more powerful by upgrading the kitchen. And they're so versatile they can handle pretty much any recipe you can dream up. But, of course, there's always a flip side. All that complexity means our recipes, our software, often have mistakes or bugs. And as we just saw, performance is almost always held back by waiting for ingredients. Not to mention, our kitchen needs a ton of electricity and it has to be kept cool, and it's vulnerable to bad actors who want to mess up the whole operation. And this whole setup leads to some really classic mistakes. Sometimes developers forget to clean up the countertop when they're done, which causes what we call a memory leak. Other times, they might just assume the pantry is bottomless. A really common one is making the only cook in the kitchen stop everything just to wait for a slow delivery from the pantry. And it all stems from the biggest myth out there, that just getting a faster cook will solve all your problems. Which brings us right to the end here. The next time your computer is acting sluggish and you start thinking about an upgrade, just ask yourself, is the cook really the problem? Or is the cook just spending all their time waiting around for ingredients from a cluttered countertop or a pantry that's way too far away? Understanding the kitchen, my friends, is always the first step to making it run faster.